Hi folks, this is about various different circle theorems. So in maths there's a number of theorems that kind of deal mostly with the angles within circles. So I'm just going to go through each one and explain some of them. So the first one here is that the angle subtended at the center of a circle is twice the angle at the circumference. So just to try and explain it a little bit, if you were to take an arc on a circle, so an arc would be around there like that, and we'll just take the 2 points at the ends of those. So if I'm to draw a line to the far side of the circle, so it could be anywhere along it, just leave it there maybe, and then from the other one, and it meets it. Well, if I'm to draw another 2 lines from both of those points to the center, well then what the theorem says is that this out here has to be half of what this is here. So if that angle there was 40, well then the one at the center would have to be 80, and that's all the theorem states. So that when it's so it means by subtended at the center of the circle from the arc. So that's all that theorem really says. The next one, angles at the circumference on the same arc are equal in measure. This is hard enough to see, this one. So again, if we start out with an arc along the bottom, I'm just marking in the 2 points there that where the arc starts and finishes. So if I'm to draw a line from both of them, from there to the far side of the circle, kind of like I did the last time, so that where they meet, well, if I do exactly the same thing now again, so that they meet somewhere else. So for example, I could go up here and the one from the other side meets it. Well, then both of those angles have to be equal, no matter where I drew them. So if I go back, if I drew the second one somewhere else, for example, so just say I draw it up there now. Well, then still that one and that one, they have to be equal. So no matter where you draw them from them, okay, as long as they go from the same points along the arc. So that's that one. Right, this one a little bit simpler to see then. So all this is that each angle in a semicircle is a right angle. So if I was to draw any diameter of a circle, so we'll just say that's a diameter. If I draw a line from both places, from both of the points at the ends of the diameter, if I'm to draw anywhere along it, it has to make a right angle. So that there has to be a right angle. If I drew it somewhere else, so if I drew it towards the middle, again, that has to be a right angle there. So it doesn't matter where, as long as you draw it from both ends of the diameter, 2 lines to the circumference, it has to make a right angle. So that's that one. Right, so if the angle on a chord at some point on a circle is a right angle, then BD is a diameter. So this one then is not really related to that picture I have there with it. It's more to do with the last one again. So if you have it's the same thing as really what I've just said a minute ago. So if you have a right angle anywhere along it, if that's a right angle, well then they have to go to the diameter of the circle. It's kind of just the opposite way around. So if you have a right angle anywhere along here from 2 lines, well then they have to go to make a diameter. They have to make a diameter from it. The next one then is just, so the sum of opposite angles of a cyclic quadrilateral. So a cyclic quadrilateral just means a quadrilateral within a circle, just where. So a quadrilateral is a four-sided shape. That's what quadrilateral is, any four-sided shape. So if you make any four-sided shape within a circle, like here, well then the opposite angles have to add up to 180. So if I picked any 4 points along that there, so just pick one there, maybe, one there, and one there. So I could pick any 4 points along it. So then the opposite angles, they have to be the same. So that angle and that angle have to be the same. And this angle and have to be the same as well. Or sorry, they don't have to be the same, but they add to 180. So I'll try to label them a bit clearer. So if that's angle A, that's angle B, that's angle C, and that's angle D, well then A plus C there would be equal to 180, and should be B, so B plus D is equal to 180 as well. So opposite angles in a cyclic quadrilateral are equal to 180. I think this is the last one I'm going to show you. So again, it's simple enough one to see. So if I'm to take a center point circle, and then I'm to take any chord, so I could draw a chord anywhere along it, I'll just draw one there. If you're to drop a perpendicular of the chord, so the perpendicular, if you're to draw a line from the center down to the chord at a right angle, well then it has to bisect the chord. So if that's 5 centimeters, well then this has to be 5 centimeters as well. So it looks like it looks like it has to be the same anyway. It's easy to see it, but there's a circle theorem which says that it does have to. So that's it. So it's just, the important thing here is just seeing it, understanding, and just remembering each one, and remembering that each theorem exists, because you'll have to adapt them around to answer questions on it then.